Alright guys, Doozer shop here. A couple people in the YouTube machining community have Pratt Whitney lathes. Kimberzelix got a 12B. Foxberg's Fabrications has a 12C. I've got a 12C late model, which is the square head. And I noticed something on Foxberg's last video about how he was using the cross slide stop. And in the Pratt Whitney manual it says it's a cross slide stop, but it does not explain anything about it. And mine worked the same as his until I took it apart and figured out it wasn't working right at all. But let me show you here on the lathe what this cross slide stop is all about on the Pratt Whitney 12C lathe. And it's for threading. And you may not have known that. I didn't know it, but let's get into it here. Alright, hopefully you can see that. So what we're talking about here is this lever, alright? Now, what the deal is, it's not for locking the cross slide per se, right? So what it does is this. If you are doing some threading, and what you want to do is you want to set a 0 for your scratch pass, you come in and what you do is you're going to be infeeding. Really can't see it. On your compound, you're going to be doing your infeeding. Yeah. Your compound is up here. You're going to be doing your actual advancement of your thread with this. You're going to set this at 30 degrees and you're going to do your infeed with that. But as I said, what you do is you set your actual 0 on the dial here, right? You set your 0 and then you engage this lock. Now what that means is you cannot turn this clockwise anymore. See? And go counterclockwise, but can't go clockwise. See, let me set the handle at 12 o'clock and then lock it up, right? Now, it won't go. It can go counterclockwise, but it always brings you back to that same spot. Clockwise, it's like 2.5 turns, and it stops again. You would never go back that far. Usually a turn is all you'd go out. So you'd basically cut your thread, and when you reach the end of your thread, give it 1 turn backwards, reverse your threading, come back in, thread forward, pops to the end, pull out, reverse your threading, come back to the beginning, pops out, come back in, got that 0 stop, and do your threading. Do your threading pass. So that works, but that's what that's for. See? And it stops. If you loosen that, then you can go forward or backwards or forward or backwards. So I was talking to Foxberg, and I think he gets what I'm describing, but I'm going to take this apart and show you guys that have a Pratt Whitney 12C lathe. So you got a big nut here that you got to take off. Last time I had it off, I drilled it for a spanner wrench. So yours, you're going to have to use a socket. I think it's like 1 5/16 or something. I don't know. But mine, like I said, I just set it up for a spanner wrench, a face spanner. So that works. So you can watch, I'm just going to take this off, take the nut off. I'm going to set that up there. Now when you pull this off, there's 2 screws here. even get you a little bit more boombastic with all that. There's 2 screws there. These set screws adjust the drag tension on this, and I've never seen a lathe like that. And if this is balanced, you'd never want drag tension. But I leave these completely slacked off. There's a spring behind each one and a brass pad. The brass pad's gonna fall out maybe, so get ready to catch it. Nope. But I'll show you what those look like. Alright? There's springs in there and whatever. This hole is just a metal saver in the casting. Those are called metal savers. So that's what that is. And you might want to take time and, you know, clean your dial. I wire brushed the heck out of this thing so the numbers are legible. So anyways, so that's that. Set that down. So now you're left with this here. What you want to do is get, where's the Allen wrench? 3/16 Allen wrench, and there's 3 Allen screws here. Take this cover off. And you don't have to have them tight. Alright, so let me take these off. Sit there. Sit there. Sit there. Okay, now, so this cover is going to come off. It's on dowel pins. A little bit. Alright. So this cover comes off. Well, actually, before I pull that off, I want to take this off, right? I'm going to take off the handle. Just use an adjustable wrench. It's got wrench flats on it. I gotta get the back side. Use a small wrench. Alright, so, alright. So yeah, you got take this off, loosen it. So this is the handle, right? It's just a handle with 2 wrench flats. That's all it is. Just a handle, 2 wrench flats. Okay. So that's off, and then you have to thread the knuckle off. The knuckle. Alright, there's the knuckle. Oh, sorry. That is the knuckle, and it's got threads for the handle and threads for the pull rod. All right, so that's that. And then what I did is I added a needle bearing. I don't know if that's going to focus. I added a needle bearing, and then there's this washer, and sorry, it's a washer and a needle bearing. Okay, and there's springs behind this washer, so you got to watch it. The springs behind that washer, so I'm going to set them down. And so there's springs behind here. You don't really need to see it because you just got it. You'll just see it. They're like 3 big pen springs. So anyways, so this cover comes off, okay? Just like that. It's got red paint on the inside. And I had this off before and cleaned it all. So now what you got in there is a gear, right? And this thing is the pull rod with the threads on it. So I guess, oh, you know what? This comes out. So this is the spline thingy for your cross slide. You can see it just pulls out, right? I'm just taking it out, and it's on a spline. So that's what it looks like. It's got a key, and it's got oil groove, and it's got the gear. And see the spline on the end of that's for your telescoping taper attachment. The 12B might be a little different, but this comes out. I'm gonna set that. Ooh, it's got grease on it now. Up there. So what we're left with is this gearbox. And now let me take the gear and the shaft out. Now it's keyed. Alright, and I think, yep, that pulls off. So what I just did is I took off the gear shaft, the gear with the pull rod, and the friction clutch. And that's how this goes on there. So let me zoom you out. All right. And that goes this way. All right. So what you got here is this assembly, right? Now, what that does is this is it goes that way. So see there is a different color bronze. You make this focus a bit. See right there? There's a pin in there. And you can see there's a pin in the gear. So when I separate these two, and you look at them, there's a pin and a pin, right? So let me put the shaft down for a microsecond. So that's what you got. These two with the pins go together. So the pins, this is like kind of like a single dog clutch. Well, it is a single dog clutch. They go together, and the pin hits that way, and it hits that way, right? So it hits there. Notice the pin is there. If I go around, it'll lock up again, approximately on the other side. So that's how this works. Now, this is the friction surface, right? There's another friction surface in there, okay? So this friction surface is supposed to tighten on that friction surface, okay? That's the friction surface. So this is supposed to be assembled into there. So when you're tightening the lever, you want that friction surface to be pressured up against the inside of there, right? That's what you want. So what you're trying to do, that's the pull rod, okay? So the pull rod, let me blank you out here. You want the pull rod to go through the gear. And tension that surface against the housing. So really what you want is this, okay? Let me leave the gear off. The gear is off. Right? The gear with the pin and the pin in the bronze friction piece, I just took the gear off, right? I just took the gear and I reassembled it with just the pin. So the pull rod, the pulling surface is that bushing, right? So that goes in the mushroom, the head on this is pulling on that bushing. Now there's a gear in there, but I took the gear off. But when you tighten them threads, right? When you tighten them threads with the handle, right? This little knuckle tightens and it's supposed to pull the bronze thingy, friction disc towards the housing. So, take that off. So what you really want to happen, there's a key in there, is this. So when you tighten this handle, right? When you tighten the handle, down here, this pull rod is going in. So instead of this bronze clutch moving, pushing on there, you want this to lock up. So this pin you want to make stationary. That's what you try to have happen. When you lock up that handle, which is back there, and the pull rod pulls through this bushing and onto that bronze disc. That bronze disc is creating friction against that red housing area to lock up that pin. So that pin is immobilized when you tighten the handle. So then that gear is still free to spin, okay? And that gear is coupled. It's always the wrong way, right? There you go. So this gear and that gear, the small gear being on the cross slide, the big gear being one with that pin, that's how you get 2.5 turns. This is a gear ratio there. So this big gear can only, when the clutch is locked, go back and forth like a little less than a turn. But because the gear ratio, it allows the cross slide to turn like, what, 2.5 or something turns. But the key is to have that gear spin. So, if that bushing gets compacted over time, this mushroom head pull rod is going to tighten against the face of that gear. That's not what you want, right? So you don't want that right there to lock up. You want this thing to be able to tighten on that pull rod, lock up the clutch, and still have that gear spin. See how it spins? See how it's hitting that pin and hitting the pin? Obviously there's no tension on it, so I can just turn the whole clutch disc, right? But if that was really sucking down hard, it would be immobilizing that bronze clutch disc, and that wouldn't move. It would hold it just like that. The problem with Foxberg's lathe is that that bronze is, when you get the stiction from the problem with Foxberg's Pratt Whitney lathe is over the years that bushing has compressed, and now that mushroom head of the pull rod is rubbing on the gear, right? So really, that has gotten shorter over time. The end of that has become compressed. Because see, they chamfer it and everything. they shouldn't chamfer that. Look at that chamfer, because the chamfer takes away surface area. And that just mushroomed over, rolled over time. And then this gear, it was clamped together. This gear should always move on here, even when that mushroom head stud is clamping, the pull rod stud is clamping. So what I did is I machined away, actually I ground away that steel shoulder on the gear. You can see the crosshatch grinding pattern. I took 5/1000ths off that gear to make it slimmer, to make it thinner, right? So when the mushroom head of that pull rod is tightening against that bronze sleeve feature, that it still allows the gear to move, right? You always want that gear to be able to move. Always, always, always. So that's what I did. So what I'm going to do, I'm going to put this back together. So this is the mushroom head on the pull rod. That's going to be inserted. And no matter how tight this sandwich is squeezed together from the pull rod, that gear should always spin. If it doesn't spin, it locks the cross slide. That's what Foxberg's lathe is doing. When he's tightening his handle, it's locking this gear, and it should not lock the gear. It should only lock the bronze. That whole face is a clutch. That whole face in there, the machine face, is a clutch. So that's what you need to do, Foxberg, is you got to machine the, in my case, I just machined out 5 thou and it still seemed to have clearance. Machine 5 thou off this side of the gear hub, and your lathe will work as the factory intended it. So I'm going to stick this back in here, right? And I'm going to stick this back in here. I should even show you guys in. Come on. Yeah, it's always the wrong way. All right. So, as I said, put this in. There's a little light oil on everything. And then that gear here is going to fit. And the spline is going to go. And that fits in there. So that's all ready to go. This, now let me show, I can probably show you. Let me just pull that out again. Let's put the handle on. So I'm going to put on, blasted, I'm going to put on the washer, and I'm going to put on this needle thrust bearing. I added the needle thrust bearing. I even made an aluminum bushing inside of it. If you can see that. Just to make it, I had to reclock the position of the handle. But anyhow, so you're not going to be able to, you always go the wrong way. So I'm just going to stick this guy back around. You're not going to be able to see the famous reach around here, but it just goes on there, and there's a pin, and then this is going to go on there. Like I said, I added this because I needed to shim it anyways. Now I'm going to put on the bronze knuckle, right? So that's going to screw on. Now I've got to kind of, sorry I'm blocking your view, but I got like 6 fingers going here. All right. Get the elbow high, maybe you can see. Now that's good to go. And now I'm going to screw on this handle. Right? Beautiful. All right. Oh, so this handle, by the way, I relieved it in the lathe to make it more sexy shape. It was just a straight shaft, and I undercut it, and I used nice radii, just because it's pretty. And that knob, see how it's got the parting line in the middle? It's called a Ring of Saturn knob, because Saturn is the planet with the rings, and these old knobs are referred to as Ring of Saturn knobs. You know, if you're a machine nut, you appreciate this kind of stuff. Alright, so now, see how that spins? Right? That's how your cross slide, well, let me do it from the bottom. So you can see with the camera. You can see with the, I'll leave the camera zoomed out. You can see that spins, right? Forward, backward, spins. There's a little drag, but not bad. So when you lock this handle up, it stops. Right? It won't go anymore. It'll go back to, but it won't go forward, see? And if I loosen it, then it continues to go forward. So that's really what you're after. I know this thing, there you go, it's got to align itself here. Yeah, it's going too far. Bear with me a second, my washer is out of time. Come on, you bloody thing. There's an index hole in the washer. You dirty son of a dog. Alright. That's better. I know you can't see what I'm doing, but there's a washer. Oh, there's a hole in the washer that's got to line up with a dowel pin. All right, see, that's not traveling all the way, so that's where it's supposed to lock up. And you unlock it, and you can turn it. All right. So, sorry for that delay. Put the Allen screws back. So let me give them all just a light snug, just so they don't come loose. All right, those are back on. We're going to put on the main cranky handle. Make sure the little brass thingies don't come off. That's on. And I'll show you that screw, nut rather. I just drilled those holes in there. They're blind holes for the spanner. And there's the hub on the back so they don't come through. But I just did that because, well, because I'm Doozer. Tighten that up and get my spanner back again. And these holes are really drilled tight. Tighten that. Good enough. They're so tight, it's just, you gotta wiggle it to get it loose. Alright, so there she is. If you lock it, 1, 2.5, 1, 2.5, lock. And you loosen that. Where the heck is it there? And then you can continue forward. So that's how that works. Yeah, that's how that works. Yeah. So Foxburg, I hope you enjoyed the little video here about how that's supposed to work. If you want it to only stop the threading, to bind up the threading stop, grind down your gear face or chuck it up and turn it down or whatever, mill it down, I don't care. 5 thou or whatever. I just started with 5 thou and it seemed to be a good clearance. Kimberzelic, I think your lathe doesn't have that. I think your lathe has adjustable rods on the cross slide. You have a piece of all thread that's missing. I think it's 5/16 fine thread or 3/8 fine thread on your lathe, Kimber. That is meant to do the same thing. But the Pratt Whitney 12C, the C series, at least that's how this is supposed to work. So hope you guys with Pratt Whitney lathes of this type now maybe understand a little bit better how that's supposed to work. I didn't understand it. The manual was not clear. It just said cross slide lock. Well, it's like a threading. It's used to set the 0 on the threading. I think the Monarchs are similar. Yeah, I think they're similar from the guys that have Monarchs I talked to. But that's how that works. It's just for threading. My cross slide, let's see, has there, right? That's the lock for the cross slide. Right, for the Allen key, you got to lock it there. So that's really the gib lock for the cross slide. And like I said, a handle is just for the threading part of it. And like I say, that's I added that. The black thing is that roller thrust bearing. You know. But that's how it works. It's kind of a little confusing if you've never seen this before, which I had never seen it before. But I don't know. I hope Foxburg you get something good out of this, and